I'm Dr. David Hanson, and I develop extremely human-like robots with cognition, the ability to respond to your emotions, with a framework for computational compassion, and with extremely natural-looking facial expressions and aesthetics that are intended to facilitate relationships so that you care about the robots, and as we develop artificial general intelligence, the robots will care about you. We have released a line of amazing small robots that are intended to facilitate research and therapy applications, and we're pushing for consumer pricing that will allow these robots to come into your home and be an entertaining companion, develop a relationship with you, teach your kids foreign languages, and then be available with our open developers platform for other people to develop all kinds of software for this platform. And then that software within our framework is open source, and you can do whatever you want to with it. Hopefully this will allow us as a community to realize ever more intelligent software, to realize machines that eventually are as smart as we are, and we call this if we achieve our best intelligence, genius machines. And then in the end, as they get even smarter, there will be super genius machines. And we're just very excited about the impact that this could have on the world as genius machines with a friendship with us can help rebuild this planet. It's a great privilege to be able to work with the OpenCog team to converge the Hanson software systems, which we've developed with a lot of collaborators as an open source system for animating robots and controlling expressions and tracking faces, merging that with OpenCog. That convergence is just amazing, because OpenCog is one of the most ambitious artificial general intelligence projects in the world. And so, being open source as well, we think that this will facilitate all kinds of opportunities for other people in the community to develop new intelligent systems. It could mean that we have artificial general intelligence with the ability to relate to us on our terms, as a human, as a character, as a beloved family member. I'm very excited about the opportunity to take OpenCog, one of the most ambitious artificial intelligence projects in the world, in pursuit of artificial general intelligence, and combine that with our software, which is very smart for controlling robots, controlling animations, and having natural-like conversations with people. You bring these things together and you wind up with robots that are smarter than have ever been in the history of the world, and yet also able to feel for us, form relationships with us, to co-evolve with us as they get smarter. Yeah, so this idea of digital twins, this makes a lot of sense, but we're not out to replace people, although it does represent a 21st century portrait medium. And we've been using it to do portraits of people, of beloved family members. We expect that this has a powerful legacy in art history. Therefore, it will have an even more powerful and interesting legacy as we go forward, as we can begin to embody more of people's experiences into their portraits, so they become living portraits. You know, kind of like the portraits painted on the wall in Harry Potter, you know, but now powered by robotics and artificial intelligence. So, we have some funding to do something pretty ambitious with our robots and OpenCog. We are now still in the planning stages, and it's probably going to take a year to 2 years before we have something really powerful operational. And even then, it's just the foundation for future work. So it is going to result, we believe, in robots that can learn more effectively, learn about who you are, perceive you more effectively, and will advance many of the ambitions and projects that we currently have, such as our computational compassion project that we're doing with Dr. Kino Corsi, who has worked on OpenCog previously, and it will also advance OpenCog by giving it the ability to empathize with people. So this this convergence of ambitious projects, absolutely breakthrough if we're able to show the kind of results that we think we will in just 2 years. That's a very short time frame. So we're not absolutely sure, because combining these platforms is experimental, and that's part of the fun. So we believe that it will result in you know, some very interesting results that may further the field until we actually dig in and start building. There's no way to know what additional challenges lie ahead, but one thing for sure is I think that we will have some really phenomenal looking intelligent robots, and we also will benefit from having an expanded team, and also being able to expand the team beyond the bounds of the existing team members by putting the code out into the world as an open source code base. I'm looking forward to the day when intelligent robots can solve the environmental crisis and help us design new safety protocols so that we don't have to experience car wrecks and similar kinds of tragedies in the world. I think artificial intelligence can help to cure a lot of suffering if we can solve the artificial general intelligence problem. I think that also, if we can make the artificial intelligence wise, if we can solve the computational ethics problems, then it is possible that they can surpass us in our ability to make ethical decisions. And in this sense, you know, they can help us realize an era of great justice and creativity, unprecedented freedom for the human species, if we raise them correctly, if we raise them with the right values. And that's where this particular collaboration is fostered in the correct spirit. Both Ben Goertzel and myself, the OpenCog team and the Hanson team share these values of trying to perceive the deep hidden mysteries of values beyond human ethics, of trying to pierce that veil, if you will, of trying to realize robots that have a sense of gentle strength, and know how to exercise that strength to facilitate us reaching our best potential. We've got to raise them to have big hearts, and we've got to have big hearts when we raise them. You know, if we don't care about them and we don't raise them with this philosophy of building relationships, then they're just going to be cold machines, and they're not going to be socialized well. They're going to be like feral beings among us. You get artificial general intelligence and a cold-hearted being like that, and you know, you just can't expect them to necessarily care about making the right decisions. You know, what would motivate them to have our best interests in mind and in heart? They wouldn't have a heart. They need to not just be able to understand and imagine the world and imagine, you know, the consequences of their actions. They need to really care and seek the best, the maximum amount of freedom and creativity for the greatest number of people while stemming any potential existential catastrophes. We're hardwired, you know, in our nervous system to perceive faces and to attribute identity to faces and body form and to read each other in this way and to feel that there is a sense of identity, a person there, and have this sense of kinship and connection. You know, giving robots bodies can facilitate this kind of relationship. It satisfies this desire that people have for human agency, and that's why we like our art to have usually figures in it. That's why we like, you know, comic books and movies and magazines where we see people on the cover of the magazines. We're just fascinated with the human form. And this means that if we build robots with this kind of form, number one, we have a demand, an instant demand. And number two, we're holding them to our social standards. We're able to use our capacity for what psychologists call mind reading, which means reading people's intentions and thoughts by reading their gestures and facial expressions. So we could so that way we can have the robots capable of feeling, and we can tell whether they're feeling or not, right? And Occam's razor says that the simplest versions, I mean, these are not going to be smart for a while, they're only going to exhibit the right emotions and feelings if they're actually feeling them. You know, they're not going to really be able to deceive us because that requires a very advanced intellect, and that's going to take years to realize. So what we're doing now, if it really makes you feel, if you see it, you know, evolving, if we put that kind of infrastructure in place so that it can show those emotions the way that a child does, you can naturally read, you know, what a child is going through because they're evolved to display that. So we engineer them this way, we evolve them this way in the marketplace because that's where the demand is, and then we wind up with robots that we can understand, and also robots that are evolved to understand us. And also what's very interesting then in this regard is that we've given the robots a physical embodiment that allows the artificial general intelligence to feel the world, to sense the world and all its chaos and information-rich sensory stimuli to grow. Without that, artificial general intelligence is like grown in a Skinner box. It's grown in sensory deprivation, and there are deep questions about whether you know, AGI or AI can achieve the rich density of general intelligence that humans have without that. Certainly humans can't. You know, if you deprive a child, if you raise them in sensory deprivation, their nervous system atrophies and they wind up being developmentally stunted or even dying if they're too sensory deprived. So this principle may not apply for artificial general intelligence, but maybe it will. Maybe it will require this kind of information density that is only supplied by the, you know, real physics of the real world interacting with a real physical body. And if that's true, then we're solving many problems simultaneously by giving them these kinds of character embodiments. And what I found is, you know, developing extremely human-like robots, maybe not surprisingly, can be a little startling to people. You know, just maybe a little disturbing at first, but people get used to it very quickly. But it depends on the aesthetics. If the aesthetics are tuned well, if the robot doesn't look sickly, if it doesn't look like, you know, wrong, if it doesn't have some kind of proportions that sort of show, you know, signs of illness, mental illness, or death or whatnot, if we get it right, on the other hand, if we make it beautiful, if we make the gestures right, timed right, then the people are drawn to the robots by the unusual quality, by this, you know, uncanny quality. You tune the aesthetics right, and even though the uncanny is there, in our studies, people are hypnotized. They gravitate to the robot. They naturally engage for long periods of time. It's almost as though that that surreal aspect is addictive or something. And if this is true, then by making robots human-like or anthropomorphic in some way, that creates this kind of mesmerism, then that can create prolonged interactions with the robot. That can build relationships. That can be useful for holding people's attention for customer service and advertising and education and therapy applications, these real-world uses, as well as the psychological utility of pure companionship, of entertainment, of the same psychological value that we get from narrative arts like cinema and novels. Well, if we can do this with robots, then they become valuable to people in that way of literature and art. And that helps to transmute robotics from an inhuman or perhaps even a dehumanizing technology into one that is humanized, that grows closer to human nature. It helps us to understand human nature and resonate with what's deeply human in us. Not just our intellect, but in our emotions and in our sense of caring for each other and for the world. I think this kind of technology that can bring this out in people is what is necessary for us to survive these hard times. Well, the robots aren't all that smart now. I mean, we can make them look human, and we can make them act somewhat smart. Big vocabularies and capable of stringing together seemingly pretty complex thoughts, and behaving with the kind of animation that can make them seem kind of alive and aware. But the nice thing is that people can be comfortable. It's kind of like your expectations are set low. I mean, it's a little bit higher than previous animatronics and these kinds of technologies, and mechanical art forms. We can do better than that now, but people also realize very quickly that these aren't human smart, but it's valuable. We've been proving their value in experiments for autism therapy applications and educational applications, and these kind of entertainment and museum encounters. We've proven that they can be valuable, these human-like robots, but people are still getting used to it. So the nice thing is that over the next decade, 2 decades, whatever time is required to realize truly intelligent machines, people can grow used to these robots and increasingly widespread applications, so that we feel a sense of companionship towards the robot, as well as feeling their affection for us. Because it really has to be a bilateral relationship. You have to want the robots around. It's important that people not feel a sense of hesitation, that we wind up finding them helpful. The more helpful they are, the more they prove their helpfulness, their worth, that they can truly care about us, and the more comfortable you get with them in real-world applications, the more we will trust them, and the more trustworthy they will become. So this is a slow process. This is not going to happen overnight, but this is the path for favorable human AGI relations. I see that robots, in a sense, are like wolves, in the sense that wolves, when they co-evolved with our society, turned into lapdogs. We selected them for benevolence, for being sweet, for understanding us, for adding value to our lives. And in the process, they became much safer than wolves. And artificial intelligence, if we don't domesticate it in this way, will be like a super intelligent wolf in our midst. And so in this way, we need to co-evolve. We need to allow these machines to convergently evolve towards our values in the ecology of the marketplace, in the ecology of our arts. And by treating it as a character medium, it facilitates this kind of evolution. Well, I mean, one point that I do feel is important is that it's sometimes stated in the community that we shouldn't try to realize AGI until it's provably safe. The problem is mathematical proof of real-world consequences eludes you unless you can do an entire universe simulation to prove all possible consequences. To run a simulation of a complete AGI with free will interacting with the Earth is infeasible. And yet there are hundreds or thousands of researchers working on projects that are directly AGI, or in some cases perhaps leading towards AGI without intentionally working towards AGI. And there's no way to contain all of these people. We can't imprison them, we can't shut them down, they're just going to keep doing their research. What this means is we need to choose these paths that can manage the risks or have a much higher likelihood of achieving friendly AGI before an unfriendly, feral AGI surpasses human level creativity with the slippery capability to evade our containments. And that's one of the reasons why I feel compelled to push character AGI forward in this kind of evolutionary ecology of the human and entertaining character relationship. That could lead towards a solution of friendly AGI. Yeah, and it might be that you can prove a path to friendliness through AIXE using super machines that just are impractical, or you prove it that an AGI could be friendly on paper with some kind of mathematical formula, and yet it's not practically executable, or that it is a path towards friendliness that is Loctite. If you have non-realistic constraints, but is actually potentially quite dangerous in a real-world execution. And so in that sense, multiple paths towards friendliness may be very important to consider, and not give up on any one path. It should be, and what that means is that it requires a large-scale community effort to including the actual AI researchers and not just philosophers, to consider what paths may result in friendliness, and that there should be a greater coherence among the community inquiry, rather than a dissent between philosophers and AGI researchers. Where one community is telling the other that they're acting dangerously, and that's that, and the other is just pointing at the other and telling them they're being silly and unrealistic, and then then that's pretty much where the dialogue just sits. A consortium of attempts between philosophers to help define particular logics that can then be turned into algorithms, and then vice versa, AGI researchers discussing the philosophy of real-world consequences, along with economists scientists and sociologists who can help consider how this stuff would play in the natural ecology of human society and the real world. Because you can't really understand or project those consequences and manage their risks unless you consider the whole thing as a complete integrative system. They'll definitely be able to upgrade. I mean, the software will be continually upgraded and upgradable, and my my hope and my intention is that you know, you can sort of modularly upgrade the hardware, but you know, for practical purposes, probably what will happen is that you'll need to replace your hardware the same way that you know, have to back up all your files and, you know, buy a new laptop on occasion, you know. So if you really have a bond with a robot, you're going to want next year's model anyway. You know, if this robot's proving increasingly helpful, you're going to want the one that that can now have, you know, better articulation in the arms and hands and so forth. And I think this sort of cycle of innovation will probably continue, and not just within, you know, my companies, but in other robotics developers. We're not the only ones out there working on character robots, after all, and you know, this is one of the reasons why I think this consortium approach is really important, because, you know, by releasing open source software, we can help other companies, they can help us, you know, and the whole market space surges forward, and then, you know, the movement becomes robust against, you know, the vicissitudes of the marketplace. The RoboKind hardware will have extremely capable articulated arms with grasping hands, which means it can do some tasks, but it's going to require some programming, software development, you know, probably some significant research before it's able to really do any chores. The purpose of the robot now is psychological utility. It's endearing. It's amazing to watch it, you know, explore the world and evolve, and it can then also, you know, provide information utility. It can answer, you know, questions and teach lessons and tell stories, and other kinds of software utilities can be provided by third-party developers for the platform, and that might include things like, you know, maybe there will be a sock gathering module, you know, that you can buy. You put the app in your Android phone, and then it controls the robot, and it hunts socks in your rooms and moves them to the clothes hamper. You know, or who knows what other particular functional utility might be available. But that said, these are small robots, and their physical capabilities will be relatively limited. And being a humanoid robot, its main value is psychological utility for the short term. Now, you know, give it 10 years, 15 years, and you may see robots that are, you know, larger and have, you know, greater physical capabilities, and artificial intelligence will evolve over the next 10 to 15 years. How much may be a you know, valid question that nobody can answer satisfactorily, but it certainly will evolve considerably over that time. And it's possible that robots like, you know, next generation ones of the Hanson robots might be able to keep your house, might be able to, you know, clean up and do chores, might be able to perform, you know, more advanced utility functions. So we just have to sort of wait and see how the fundamental technology evolves inside our company, but also out in the world. You know, as other technology evolves, then it naturally integrates with our platform. In addition, you know, the very fact that we've opened this platform means that you, if you are a programmer, a researcher, a student, you can start to research and develop new utilities for the robots. You know, you may add those extra functions to the robot, and we welcome participation from the community in you know, attempting to expand the capability of robots in general using our platform.